Hey everyone, I'm Eddie. Welcome to the channel. I put together a free SAT math problem set that you can grab right now using the link in the description. No fluff, just targeted practice, because the fastest way to an 800 is repetition on the right problems. Let's get into it. Number one, consider the equation that's given, where k is a constant. Reminder that a constant just means any number, just any number. This equation is true for all x when x is not equal to 2. And that makes sense because if x were 2, we'd get zeros in the denominator. We can't divide by 0. Now, what would the value of k be? Students, don't waste your time dividing by x minus 2 here. Just simply multiply both sides by x minus 2. Then we'll get 2x squared minus kx plus 4. And on the right, the x minus 2's will cancel out in this fraction, and we're going to be left with something like this. And we don't even have to distribute this out completely. I just want the coefficient of x. So I know negative k will equal 3 times x plus 2 times negative 2. So negative k is equal to negative x, or kx and x. So therefore, k will equal 1, just like that. Number two, the table shows the colors and shapes of a table. If a table is selected at random, what is the probability that the selected tile is neither gray nor circular? So none of these, none of these, none of these. So we're left with 25, 5, 5, and 15. Those add up to 50. Out of a total of 100, the probability is 1/2. An easy one there. Number three, two data sets A and B both consist of 10 integers. Data set A has a mean of 40 and a standard deviation of 6. Data set B is created by multiplying every number in the data set A by 2.5 and then adding 20 to each result. What is the standard deviation of data set B? We have to be very careful here. With standard deviation, when we add the same amount to each result, the standard deviation does not change. But when we multiply every number in a data set, we multiply the standard deviation by that same amount. So the standard deviation was 6. 6 times 2.5 will give us 15 as our new standard deviation for data set B. Number four, a virus breaks out at school on Monday and the number of infected people doubles daily. Let's think about that for a second. If we started off with 3 people having the virus, the next day would be 3 times 2 after a day. The next one would be 3 times 2, but times 2 of that because it doubles daily. So this is equal to 3 times 2 squared. So we kind of already have some structure that we're building. We're definitely going to have some 3 times and 2 as the base. So we have a 2 as a base here, 2 as a base here, 2 as a base here. But the number of days will be determined by how many times we double. So we have 3 times 2 cubed here. That's how we know letter B will make the most sense here. Number 5, during the summer months, the number of hot chocolates, H, sold per day is modeled by the function H is equal to this linear equation with a negative slope. Now let's make sense of this really quick. X stands for the average daily temperature. So as the temperature goes up, it makes sense that the number of hot chocolates sold is going down. Boom, there it is. As the temperature increases, the number of hot chocolates sold decreases. Just very simple linear equation things going on here. But wording is dense. That's why I put it into this 800 score problem set. Number 6, we need to know our equations of circles. A circle in the xy plane is defined by this equation, x squared plus y squared plus 6x minus 10y is equal to 2. If a line passes through the center of the circle, so we're going to have to find the center of the circle, and has a slope of 2, find the y-intercept of this line. Very simple problem. We're going to find the center of this circle by completing the square for each x and y. Then we'll use point slope using the point of the center of the circle and the slope of 2. We're going to isolate for y, and that's how we're going to get our y-intercept. Or in other words, we can plug in 0 for x, and that'll also give us our y-intercept. Let's complete the square. We'll have x squared plus 6x. We're going to be adding a 3 squared to this, plus y squared minus 10y. We're going to be adding a negative 5 squared to this. On the other side, we have a 2. We're going to be adding that 3 squared and that negative 5 squared. In total, we have x plus 3 squared plus y minus 5 squared. We don't really care what's on the right side here because, again, We only need the center of the circle. The center of the circle is negative 3, 5. We know that our slope is 2. Let's use point slope. And once we plug in x equals 0, because that's how we get the y-intercept, any point on the y-axis has x equal to 0. That'll give us negative 6 here. Add a 5. Y is equal to negative 1. Oh, let's try that again. Plug in a 0. This should be x minus a negative 3. Whew, glad I caught that. X minus a negative 3 here. So we have positive 3 times 2 is 6, plus the 5 gives us an 11. Good thing this wasn't a grid and answer, or else I would have made that mistake. Don't make that mistake that I just did as well. Good thing we fixed it as well. Number 7, the equation here has exactly one real solution for x. Now let's take a look at this quadratic equation, and we can recognize something here. That's not a 6. It should be a b. It should be a 64. Think about what exactly one real solution means. Now we can use the discriminant, and we'll do that in a little bit, but I also want you to practice recognizing patterns. X squared is x, 8 squared is 64. So if we were to have just exactly one real solution, I know that it's going to be a binomial squared. B then will equal 16. Another way you could have done this. B squared minus 4ac is b squared minus 4 times 1 times 64. This will give us b squared minus, this is 256. And we're going to set this equal to 0. So that's how we can also get b is equal to 16. Now, they want us to find what the value of h and k is, depending on what the vertex is. Well, if our exact one real solution is at x equals negative 8, we know that y is equal to 0 at x equals negative 8. That's negative 8 comma 0. If we add these up, we get negative 8. Plain and simple. I gave you 2 ways of doing this, by the way, right? 2 ways of doing this, and both of them would have gotten you to the answer almost at exactly the same amount of time. Number 8. In the system of equations below, a and b are constants. If the system has infinitely many solutions, that means those 2 equations will be identical. We will have identical equations here. So we can say a is to 4, as 3 is to a plus 1, as 12 is to b. We can set up a proportion because these all have to be equal. We can use the first 2 fractions to solve for a. We have a times a plus 1 will equal 4 times 3, which is 12. Now what does a have to be? Clearly it has to be 3 because 3 times 4 is 12. Now we can figure out what b is, because we know that if a is 3, then 3/4 will equal 12 over b. Well, we multiply by 4 both on top and bottom. B will therefore be 16. When we add a and b, we get 19 for a plus b. Just like that. Keep it simple. Number 9. In a right triangle, cosine of 90 degrees minus theta is equal to something, and sine of theta is equal to another. Now, if you look at a right triangle, let's label this theta. Let's label, this is opposite, or actually let's label it ABC. That might be much easier. ABC. Sine of theta will be opposite over hypotenuse. Cosine of 90 minus theta, notice how this right here is 90 minus theta. Cosine of 90 minus theta is also equal to a over c. So what they just told us in the problem is that these 2 things are equal. Find the value for cosine of theta. If we set these 2 equal to one another, we're just going to be left with k plus 2 is equal to 3k minus 6, because they have the same common denominator. That was repetitive. The same denominator. So we'll have 2k is equal to 8 and k is equal to 4. Now what does this do? We can plug the k equals 4 back into our equation. And cosine of 90 minus theta was k plus 2 over 10. That gives us 6 over 10, which is 3 over 5. So check this out. A is equal to 3. C is equal to 5, therefore B is equal to 4. I want to know what cosine of theta is. Cosine of theta is adjacent over hypotenuse. 4/5 is our correct answer here. Very neat trigonometry problem here. Number 10. We have an equation for all x is greater than 3, and this is needed because x needs to be greater than 3 in order for everything within this square root to be positive, to be non-negative. And x and k is a non-zero constant. What is x in terms of k? Well, square both sides. We'll get x squared minus 9 is equal to x squared minus 2kx plus k squared. The x squareds will go poof in the night here. They're going to eliminate. And once we get rid of that, we're left with something like this. We want to solve for x so that we have x by itself, and we can write that in terms of k. We're going to go ahead and subtract k squared from both sides then. Negative k squared minus 9 is equal to negative 2kx. Notice how everything is negative? Let's make everything positive. So I have x squared plus 9 is equal to 2kx. So then here we'll have x is equal to k squared plus 9 all over 2k. Let's check our work here really quick. When we square both sides, we get x minus 2kx plus k squared. We go ahead and eliminate the x squared. So negative 9, subtract negative 2kx, divide both sides by 2k. Yep, D would be correct here. Very nice. Now 11. In a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. So 5 pi over 4 is approximately, it's actually a pretty wide central angle. 5 pi over 4 would be something like this. And there is our angle. This is 5 pi over 4. And the area of this sector is formed by central angle AOB is 40 pi. One time around the circle will be 2 pi radians. 2 pi radians is 1 revolution around a circle. So if we took a proportion of that, 5 pi over 4 of that 2 pi, and we took pi r squared of the entire circle, that's what's giving us 40 pi. That's the area of a sector. A sector is just a section of that circle. Now the pi's cancel here. Pi's cancel here. So we have 5/8 r squared is equal to 40. Multiply both sides out. And then we'll get 8/5, 864. And r will then equal 8. I want to know what the length of this arc is right here. In order to figure that out, I need to find the circumference of the entire circle first, which is 2 pi r. That's 16 pi. And I'll be taking the same proportion. 5 pi over 4 of 2 pi times the 16 pi, and that's what my length of the arc AB will be. Again, pi's cancel. We have 5/8. That makes this a 2, so we have 10 pi as our final answer. Last one, let's get it. The polynomial p of x is defined by this equation, where k is a constant. If x minus 4 is a factor of p of x, the factor theorem. If x minus 4 is a factor of p of x, that means I know p of 4 will equal 0, because that's what makes x minus 4 0. If we have a factor equal to 0, anything times that 0 will give us a 0. So that's how we know p of 4 is going to give us that 0. Let's plug in 4 into all the x values we see in p of x. That gives us 4 cubed minus k times 4 squared plus 2 times 4 minus 8. We know this will equal 0. Thankfully, we only have one variable left. We can solve for k, and then we can solve the remainder of this problem. So we have 64 plus 8 minus 8. These will go poof in the night. So we have negative 64 here, negative 16k. So k is equal to 4. We now have a new p of x equation. P of x is equal to x cubed minus 4x squared plus 2x minus 8. I want to know what the remainder is when p of x is divided by x minus 2. Well, I can plug in p of 2 then, and that will give me the remainder. So p of 2, plug it in, we get 8 minus 16 plus 4 minus 8. We get negative 16. Negative 12 looks like would be our remainder. Another way to do this would be to divide long division, right? Long division through this. We can also use synthetic division. We can use 2 here. we could say 1, -4, 2, -8. Bring the 1 down, have a 2, add up, -4, add up, -2, multiply, add them up, -12 would again be our remainder. If this was helpful, hit subscribe. I'm posting a lot more SAT math content breaking down specific topics, the traps that tests love to set, and exactly how to push from a 600 to a 700 and from a 700 to that 800. Drop a like if this earned it. It genuinely makes a difference for the channel. And comment below with the SAT math topics you're struggling with most. I actually read every single one, and your comments directly shape the problems I build for future videos. If you're serious about hitting that 800, don't stop here. I've already covered a ton of specific question types and common misconceptions in my other videos. Go watch those next. I'll see you there.